Welcome back. The CIA just invoked national security protocols over a comet. Let me say that again. The Central Intelligence Agency used the same classification language they reserve for nuclear weapons and spy satellites to avoid discussing a chunk of ice supposedly drifting through our solar system. On December 31, 2025, when researchers filed a Freedom of Information Act request about 3I Atlas, an interstellar object currently near Jupiter, the CIA responded with 4 words that change everything: neither confirm nor deny. This is the Glomar response. It's what you say when even acknowledging a file exists would reveal state secrets. It's what they said about stealth submarines during the Cold War. It's what they're saying now about a comet. 6 weeks earlier, NASA told the world this same object is definitively natural. A press conference. Absolute certainty. Case closed. But if it's just a comet, why is the CIA treating it like a threat? Why are we getting 2 completely opposite responses from our own government? Because the data doesn't match the story. 3I Atlas is doing things that violate the physics of how comets behave. And right now, it's approaching Jupiter, our last chance to observe it before it disappears back into interstellar space forever. So let's look at what's actually happening. The anomalies started piling up almost immediately. First, there was the anti-tail. In typical comets, solar radiation pressure and the solar wind push material away from the sun, creating the iconic tail that streams behind the comet as it moves through space. But 3I Atlas displayed something different. A prominent jet of material directed toward the sun, not away from it. And this feature persisted both before and after perihelion. That is not how cometary jets are supposed to work. Standard models describe outgassing as being driven by solar heating, with material being expelled from the sunlit side and creating jets that generally point away from the sun, or at angles determined by the comet's rotation. An anti-tail jet, one that defies the radiation pressure and points sunward, suggests a mechanism that is either far more complex than our current models account for, or something else entirely. Then came the alignment issues. When researchers measured the rotation axis of 3I Atlas at large distances from the Sun, they found it aligned to within 8 degrees of the sunward direction. Let's be clear about what this means. The orientation of a comet's spin axis is essentially random, determined by whatever collisions and gravitational interactions shaped its history over millions or billions of years. There is no physical reason for that axis to preferentially point at the sun unless some mechanism is actively stabilizing it in that orientation. The probability of such an alignment occurring by chance is small. Not impossible, but small enough to raise eyebrows. And it gets stranger. The orbital plane of 3I Atlas, the flat disk within which its trajectory lies, aligns to within 5 degrees of the ecliptic plane, which is the plane defined by Earth's orbit around the Sun and the general plane in which most planets in our solar system orbit. Again, interstellar objects come from random directions in 3-dimensional space. There is no reason for their orbital planes to show any preference for aligning with our ecliptic unless there is some selection effect we do not understand, or unless the object's trajectory was not as random as we assume. If you want to follow this story as it develops, make sure you're subscribed, because 3I Atlas isn't done surprising us. These geometric coincidences are not fatal to the natural comet hypothesis, but they are uncomfortable, the kind of details that make you wonder if there is a missing piece of the puzzle. Let's look closer at the data, because there is one more anomaly that stands apart from the geometric oddities, and it involves chemistry. When astronomers analyze the light emitted by the gas surrounding a comet, they can identify the specific elements and molecules present in that gas by looking at the wavelengths of light being absorbed or emitted, a technique called spectroscopy. For 3I Atlas, the spectroscopic analysis revealed something unexpected. Nickel was unusually prominent relative to iron in the gas cloud. Now, nickel and iron are both common in cometary materials. They are products of stellar nucleosynthesis, and they exist throughout the galaxy in rocky and metallic bodies. But the ratio matters. In natural solar system comets, the relative abundance of these elements follows predictable patterns based on the primordial composition of the solar nebula and the processes that formed comets in the early solar system. What made the 3I Atlas measurements unusual is that the nickel-to-iron ratio was reminiscent of industrially produced nickel alloys, the kind of ratios you might see in stainless steel or other engineered materials designed for specific properties like corrosion resistance and structural strength. To be absolutely clear, no one is claiming that 3I Atlas is made of stainless steel. The point is that the chemical signature does not fit neatly into the distribution we expect from natural astrophysical processes. Could there be some exotic formation pathway in another star system that produces this kind of signature naturally? Possibly. Could our measurements be affected by observational bias or incomplete data? Also possible. But here is the crucial detail. When you combine this chemical anomaly with the geometric alignments and the anti-tail jet, you start to accumulate a list of features that individually might be explainable, but collectively create a pattern that resists easy interpretation. This is where the scientific method should kick into high gear. You have an object displaying multiple unexpected properties. The next step is not to immediately conclude it is artificial. That would be wildly premature and scientifically irresponsible. But the next step is also not to declare the case closed and move on. The next step is to ask hard questions, to propose multiple hypotheses, to gather more data, and to engage in the kind of rigorous debate that science thrives on. So, what does this actually mean? Why did NASA officials stand at a press conference on November 19, 2025, and state decisively that 3I Atlas is definitely a comet of natural origin? Full stop. End of discussion. The most charitable interpretation is that the comet hypothesis remains by far the most likely explanation, and in the absence of extraordinary evidence, scientists default to ordinary explanations. Comets are weird. They do unexpected things. Every time we study a new comet up close, we discover behaviors that challenge our models. Maybe 3I Atlas is just unusually weird, a statistical outlier that happens to combine several rare features in one object, and over time, as we study more interstellar comets, we will see similar objects and our models will adapt. That is a perfectly reasonable scientific stance. But it does not explain the CIA response. If the scientific community is confident that this is a natural object, if the data unambiguously points to a cometary origin, If there is no serious possibility of this being anything other than an icy rock from another star system, then why would the CIA invoke the neither confirm nor deny protocol when asked about records related to 3I Atlas? That protocol is not used lightly. It is a tool for protecting information that, if disclosed, could harm national security or reveal sensitive intelligence activities. It is the response you give when you cannot afford to even acknowledge whether you have been paying attention to something, because the mere confirmation that you were investigating implies the matter is serious enough to warrant investigation. So, what are we to make of this contradiction? One possibility, the one being suggested by some researchers, is that this represents a deliberate two-track approach. Publicly, NASA delivers the most scientifically probable interpretation, which is that 3I Atlas is a natural comet, in order to prevent public panic or widespread speculation in the absence of definitive evidence. Meanwhile, behind the scenes, intelligence agencies treat the object as what risk analysts call a black swan event, something with a low probability of occurrence but such a high potential impact that it must be taken seriously and monitored closely. This is essentially a version of Pascal's wager applied to planetary defense. If there is even a small chance that an interstellar object could represent a technology from another civilization, the consequences of ignoring that possibility are so severe that the rational approach is to investigate thoroughly, even if the probability seems vanishingly small. This would not be the first time that intelligence agencies have operated on a different risk calculus than the scientific consensus. The lessons of September 11th, 2001, and other intelligence failures have made it clear that dismissing low-probability, high-impact scenarios can have catastrophic consequences. The metaphor being invoked here is the Trojan horse. The residents of Troy saw a large wooden structure left outside their gates. It appeared to be a gift, a religious offering, something benign. They brought it inside the city, and the rest is legendary history. The point is not that 3I Atlas is a Trojan horse in any literal sense. The point is that when something unusual appears from outside your borders, the cautious approach is to investigate it thoroughly before declaring it safe, even if it looks harmless on the surface. And so the CIA might be conducting its own assessment, independent of the scientific community's conclusions, not because they have secret evidence that contradicts NASA, but because their mandate is to consider possibilities that scientists might deem too improbable to warrant attention. If this interpretation is correct, then the dissonance we are seeing is not a conspiracy or a cover-up in the traditional sense. It is a rational division of labor. Scientists focus on the most likely explanations and communicate those to the public, while intelligence agencies quietly investigate the tail risks, the scenarios that would normally be dismissed, but that carry such high stakes that they cannot be ignored entirely. The goal is to avoid the boy who cried wolf problem. If the CIA were to publicly announce that they are investigating every unusual astronomical object as a potential alien artifact, and if those investigations repeatedly turn up nothing, then public trust would erode. Financial markets might become unstable in response to perceived threats, and when a real threat eventually materializes, the public might not take it seriously. The neither confirm nor deny response allows the investigation to proceed quietly without triggering the social and economic disruptions that would come from openly treating every anomaly as a potential crisis. Now, let's talk about what happened next, because the story does not end with the CIA's cryptic response. As 3I Atlas continued its passage through the solar system, astronomers turned the Green Bank telescope, one of the world's most powerful radio observatories, toward the object to search for any evidence of technological radio transmissions. This effort was part of the Breakthrough Listen initiative, a project dedicated to searching for signs of intelligent life beyond Earth. The motivation for this observation had an additional layer of intrigue. The arrival direction of 3I Atlas into our solar system happened to align to within 9 degrees with the direction of the famous WOW signal from 1977. For those unfamiliar, the WOW signal was a powerful narrowband radio signal detected by the Big Ear radio telescope that lasted for 72 seconds and has never been satisfactorily explained. It remains one of the most tantalizing candidate signals for extraterrestrial intelligence, even though subsequent searches of that region of sky have found nothing. The probability that 3I Atlas would arrive from that same direction by pure chance is approximately 0.6%, low enough to make the coincidence noteworthy. So the Green Bank telescope was pointed at 3I Atlas, and it listened. Specifically, it monitored the radio frequency band from 1 to 12 gigahertz over a 5-hour observation window between Aura 4:15 and Nur 9:15 UTC on December the 18th, 2025. The result: no technological signal was detected. The report confirming these null results was published recently, and several reporters reached out for comments, expecting perhaps that this would be the final nail in the coffin for any notion that 3I Atlas could be anything other than a natural comet. But here is where we need to be very careful about what the absence of evidence actually tells us. This contradicts what we previously thought about how such searches should be interpreted. The absence of a radio signal over a 5-hour period in a specific frequency band pointed in the direction of Earth does not, in fact, tell us very much. Think about the timescales involved here. 3I Atlas is on a journey that takes it through the entire solar system, from the outer edge of the Oort cloud through the inner planets and back out again. That journey takes approximately 16,000 years. The object itself has been traveling through interstellar space for potentially millions or even billions of years. Now imagine that this object, if it were technological, were transmitting a signal back to its senders, wherever they might be. That signal would take tens of thousands of years to cross the Milky Way galaxy. There is no possibility of a two-way conversation, no real-time communication, no feedback loop. Any signal sent from 3I Atlas would be a one-way message, and the time it spends in our solar system is a tiny fraction of its total journey. Under these circumstances, would we expect continuous transmission? It seems unlikely. Broadcasting continuously would require enormous amounts of energy that would need to be generated somehow and sustained over a journey lasting eons. A much more efficient strategy, if you were designing such a system, would be to transmit in short, compressed bursts with a small duty cycle, only activating the transmitter at specific intervals or under specific conditions. Moreover, we have no reason to expect that such a transmission would be directed at Earth. If the object is reporting back to its senders, the signal would be beamed toward wherever it came from, not toward random planets it happens to pass along the way. And even if it were transmitting in our direction, we have no idea what frequency band it might use. The 1 to 12 gigahertz range is where we typically look for signals because it happens to be a relatively quiet part of the radio spectrum, a natural window for communication. But that assumption is based on human reasoning about what makes sense for communication. An alien civilization might use entirely different frequencies, modulation schemes, or communication protocols that we would not recognize even if we were looking directly at them. So, the 5-hour observation window that captured nothing tells us that 3I Atlas was not broadcasting a detectable radio signal toward Earth in the monitored frequency range during that specific time period. That is all it tells us. It does not rule out the possibility of transmissions at other times, in other directions, or at other frequencies. A proper observing program, if the goal were to truly determine whether the object is transmitting, would need to monitor it continuously or at least intermittently over a much longer period from multiple directions across a broader range of the electromagnetic spectrum. That is a resource-intensive undertaking, and it has not been done. So, where does that leave us? We are at a moment where multiple threads of evidence and interpretation are pulling in different directions. On one hand, you have the scientific consensus that 3I Atlas is most likely a natural comet, albeit one with some unusual features that will require further study to fully explain. That consensus is based on decades of experience with comets, on models that have been tested and refined, and on the principle that extraordinary claims require extraordinary evidence. On the other hand, you have a growing list of anomalies that do not easily fit into those models. A CIA response that suggests someone in the government is taking the possibility of a threat seriously enough to classify any related records, and a set of observational efforts that, while valuable, are far from comprehensive. We also have the context of previous interstellar visitors, particularly Oumuamua, which displayed its own set of anomalies, most notably an unexplained acceleration that could not be accounted for by outgassing or any other conventional mechanism. The debate over Oumuamua's nature has not been settled, and now we have a second interstellar object with its own set of puzzles. Are we seeing a pattern? Are interstellar objects inherently more diverse and strange than we anticipated? Or is there something else going on that we have not yet understood? At this point in the story, I want to hear from you. What do you think is the most plausible explanation for the anomalies surrounding 3I Atlas? Do you think the scientific community is being appropriately cautious, or are they closing the door on alternative hypotheses too quickly? And what do you make of the CIA's response? Is it a reasonable precaution, or does it suggest they know something we don't? Leave your thoughts in the comments below, because this is exactly the kind of discussion that pushes science forward, not just in academic journals, but in the broader public conversation about how we explore and interpret the universe. The story of 3I Atlas is not over. Right now, the object is still making its way through the outer solar system, and it is heading toward a close pass near Jupiter. This is significant for a reason that might not be immediately obvious. Jupiter, because of its massive gravitational influence, acts as a kind of shepherd for the solar system. Its hill radius, the region within which its gravity dominates over the Sun's, is enormous, and objects passing through that region can experience significant gravitational interactions. If 3i Atlas were to deploy any smaller objects, if it were to release probes or subcomponents, those objects could potentially be captured into orbit around Jupiter, becoming new moons of the giant planet. This is not science fiction. We know that some of Jupiter's moons are captured asteroids or other bodies that wandered too close and got trapped by the planet's gravity. If there were any truth to the hypothesis that 3i Atlas is more than just a comet, if it were carrying any kind of technology or payload, the vicinity of Jupiter would be a logical place to deploy it. Jupiter offers gravitational capture. It offers a stable environment. It offers a vantage point for long-term observation of the inner solar system. The question is, will anyone be watching closely enough to notice? The current plan, as far as publicly available information indicates, is to continue monitoring 3i Atlas as it moves outward, but there has been no announcement of a dedicated mission to observe its close approach to Jupiter in detail. The suggestion has been made by researchers who take the possibility of a black swan event seriously, that we should be looking for exactly this kind of behavior. We should be checking whether 3i Atlas does anything unusual as it passes Jupiter. We should be scanning for any objects that might be released, any changes in trajectory that cannot be explained by gravitational interactions alone, any signals or emissions that might indicate activity. Unless we check, unless we commit the resources and attention to watching this object carefully through the final stages of its passage, we might never know if this swan is white or black, to borrow the metaphor that has been used. A white swan is the expected outcome, the natural comet hypothesis confirmed, the anomalies eventually explained by better models and more data. A black swan is the unexpected, the possibility that this object represents something we have never encountered before, something that challenges our assumptions about what is possible and what is out there in the galaxy. The implications of this debate extend far beyond the specific case of 3i Atlas. We are entering an era where the detection of interstellar objects is becoming routine. Advances in telescope technology, particularly the Vera Rubin Observatory, which is set to begin operation soon, will dramatically increase the rate at which we discover these visitors. We might go from detecting one every few years to detecting dozens or even hundreds per year. Each one will offer a snapshot of the conditions around other stars, a window into planetary systems we cannot otherwise observe directly. But each one will also force us to ask the same questions we are asking now. Is this just a rock, or could it be something more? How do we distinguish between natural and artificial? What level of evidence do we require before taking the possibility of extraterrestrial technology seriously? These are not just academic questions. They have implications for planetary defense, for space policy, for international cooperation in monitoring potential threats, and for the philosophical question of whether we are alone in the universe. If we dismiss every anomaly as a natural phenomenon without thoroughly investigating, we risk missing something profound. But if we treat every unusual object as a potential alien artifact, we waste resources and credibility on false alarms. Finding the right balance is one of the defining challenges of this era of astronomy. There is also a broader conversation happening here about transparency and trust. The dissonance between NASA's definitive public statement and the CIA's classified response highlights a tension that exists in many areas where science and national security intersect. How much should the public be told about potential threats that are considered unlikely but not impossible? When does caution become secrecy, and when does openness become irresponsibility? These are questions without easy answers, and they are questions that will become more pressing as our ability to detect and monitor objects in space continues to improve. The current approach, if the interpretation being offered is correct, is to manage public perception carefully, to communicate the most likely scientific explanation while quietly investigating the alternatives. That might be a pragmatic strategy, but it also carries risks. If the public eventually learns that investigations were happening behind closed doors, if documents are declassified years from now showing that the CIA was taking 3I Atlas more seriously than NASA let on, will that build trust or erode it? The answer might depend on what those investigations ultimately find. For now, we are left with uncertainty, with data that is suggestive but not conclusive, with hypotheses that are plausible but not proven. The anti-tail jet, the geometric alignments, the chemical signature, the CIA's silence, the negative radio search results, all of these pieces fit into a puzzle that we do not yet fully understand. The scientific process will continue. More papers will be published. More observations will be made. Competing hypotheses will be tested against new data. And eventually, we might reach a point where the picture becomes clearer, where the anomalies are explained by natural processes that we simply did not account for, or where the evidence accumulates to a point where alternative explanations must be taken more seriously. Until then, we watch, we measure, we debate, and we remain open to the possibility that the universe is more surprising than we imagined. If you found this deep dive valuable, if you think this is the kind of detailed analysis that deserves a wider audience, please consider liking this video. It genuinely helps the algorithm surface scientific content to more people, and it supports the continued production of these in-depth investigations into the stories that matter. The case of 3I Atlas is a reminder that science is not a collection of settled facts, but an ongoing process of questioning, testing, and refining our understanding. And sometimes, the most interesting science happens at the edges, where the data does not quite fit, where the anomalies accumulate, and where we are forced to confront the limits of what we know. As 3I Atlas continues its journey outward, back toward the darkness between the stars, it carries with it the questions we could not answer, the observations we did not make, and the possibilities we could not quite dismiss. Whether it is a comet, a piece of interstellar debris shaped by exotic processes we do not yet understand, or something else entirely, it has already accomplished something significant. It has forced us to think harder about how we investigate the unknown, how we balance skepticism with curiosity, and how we prepare for a future where the line between the expected and the extraordinary becomes increasingly difficult to draw. The universe is vast, and we have only just begun to listen, to watch, and to ask the questions that might one day reveal whether we are truly alone, or whether the cosmos is more richly populated than we ever dared to imagine. Until next time, keep looking up, keep asking questions, and keep demanding answers.